How were asteroids discovered? During the 18th century, astronomers were convinced that there should be a planet between Mars and Jupiter, according to Bode's law. Many scientists were absolutely convinced that a planet must exist between Mars and Jupiter. By the end of the century, a group of astronomers had banded together to use an observatory in Germany to hunt down this missing planet. They called themselves the Celestial Police. Despite their efforts, they were beaten by a scientist named Giuseppe Piazzi, who discovered what he believed to be the missing planet in 1801. The new body was named Ceres, but subsequent observations swiftly established that it could not be classified as a major planet as its diameter was just 940 kilometers. Instead, it was classified as a minor planet, and the search for the real planet continued. Between 1801 and 1808, astronomers tracked down a further 3 minor planets within this region of space, each smaller than Ceres. It became obvious that there was no single large planet out there, and enthusiasm for the search waned. A fifth asteroid, Astraea, was discovered in 1845, and interest in the asteroids as a new class of celestial object began to build. In fact, since that time, new asteroids have been discovered almost every year. It soon became obvious that a belt of asteroids existed between Mars and Jupiter. This collection of space debris was the missing planet. It was almost certainly prevented from forming by the large gravitational fields of adjacent Jupiter. Now, there are a number of telescopes dedicated to the task of finding new asteroids. Specifically, these instruments are geared towards finding any asteroids that cross the Earth's orbit and may therefore pose an impact hazard. Asteroids, sometimes called minor planets, are rocky, airless remnants left over from the early formation of our solar system about 4.6 billion years ago. The current known asteroid count is almost 800,000. Most of this so-called ancient space rubble can be found orbiting the Sun between Mars and Jupiter within the main asteroid belts. Asteroids range in size, from Vesta, the largest, at about 329 miles, or 530 kilometers in diameter, to bodies that are less than 33 feet, or 10 meters across. The total mass of all the asteroids combined is less than that of Earth's moon. Most asteroids are irregularly shaped, though a few are nearly spherical, and they are often pitted or cratered. As they revolve around the Sun in elliptical orbits, the asteroids often rotate. More than 150 asteroids are also known to have a small companion moon. As you can see from this image, this asteroid is largely composed of aluminum, as well as olivine and pyroxene, which are both compounds partly composed of silicon. The 3 broad composition classes of asteroids are C, S, and M types. The C-type or chondrite-type asteroids are most common. They consist of clay and silicate rocks and are dark in appearance. They are among the most ancient objects in the solar system. The S-types, or stony types, are made up of silicate materials and nickel iron. Finally, the M-types are metallic. They are also made up of nickel iron. The asteroids' compositional differences are related to how far from the Sun they formed. Some experienced high temperatures after they formed and partly melted, with iron sinking into the center and forcing volcanic lava into the surface. One of the most common elements of asteroids is silicon. In everyday life, silicon can be found in construction materials, ceramics, computer chips, rocks and sand, glass, and the skeletal system. Even though humans have been using silicon for thousands of years, it wasn't discovered officially until 1824 by a scientist named Berzelius, who was a Swedish chemist. In his famous experiment, he heated chips of potassium in a silica container and then carefully washed away the residual byproducts. Silicon is the 7th most abundant element in the universe and the 2nd most abundant element in the Earth's crust. Today, silicon is produced by heating sand with carbon to temperatures producing 2200 degrees Celsius.
How is silicon made today? Silicon is produced commercially by reducing sand with carbon in an electric furnace. High-purity silicon for the electronics industry is prepared by the thermal decomposition of ultra-pure trichlorosilane, followed by recrystallization. What are some applications of silicon in society? Silicon is one of the most useful elements to mankind and can be used to make alloys such as aluminum silicon and ferrosilicon, or also known as iron silicon. It's used to make many products in the electronics industry, such as transformer plates or other tools such as machine tools, cylinder heads, or deoxidized steel. Silicon can also be used to make lubricants, cosmetics and hair products, and waterproof sealants. Silicon is mainly used as a semiconductor for the computer and microelectronic industries. Granite and most other rocks are complex silicates, and these are used for civil engineering products. Sand, silicon dioxide or silica, and clay, aluminum silicate, are used to make concrete and cement. Sand is also the principal ingredient of glass, which has thousands of UConns. Silicon, as silicate, is present in pottery, enamels, and high-temperature ceramics. Silicon has also impacted the economy greatly. The computer and electronics industry is the main use of silicon. Only 10% of free silicon is used as a semiconductor for electronics, yet contributes greatly to the economic prosperity and growth of the industry. Silicon Valley in the San Francisco Bay Area is widely known for its technological businesses and advances. High concentrations of computer and electronics companies in the area produce silicon-based semiconductors and chips. Between 2009 and 2014, after the Great Recession, labor force and employment totals increased by 10% and 16% compared to the greater Los Angeles area. They had a 41% drop in total unemployment, and since the recession, unemployment rate has been 2.3 points below the greater Los Angeles regions since the recession. Though we generally think of coal or oil when discussing natural resources, silicate minerals are a natural resource that we cannot live without on our planet, and not just because of our increasing reliance on computers. Without quartz, there would be no glass. Without clay minerals, we would have no ceramics or pottery. We use silicate minerals in manufacturing of many buildings, including bricks and concrete. The weathering of silicate minerals on the surface of Earth produces the soils in which we grow our foods and the sand on our beaches. The properties of the minerals that are important to us are based on the versatility of the silicate anion in combination with other elements.